Hey guys, so in this video I am going over the study guide for our Unit 4 test, which is tomorrow. So for 1 and 2, we are converting into degrees. So just a quick review. Our different equations for converting between degrees and radians. So we're starting with degrees. We're going to multiply it by pi over 180 to get our radians. So if we're starting with radians, we are multiplying 180 over pi, and that is going to give us our degrees. So for number 1, we start with our radians, so we're multiplying it by pi 180 over pi. Multiplying straight across, you get negative 7,740 pi over 12 pi. Your pi's cancel out, so you're going to simplify. You can put it in your calculator and you get negative 645 degrees. For number 2, you have radians, so you want to go to degrees, so multiplying by 180 over pi again, and you get 900 pi over 6 pi. Your pi's cancel out, and you're left with 150 degrees. 3 and 4, you're converting your degrees to radians. So you need to multiply pi over 180. Multiplying straight across, you get negative 330 pi over 180. You simplify and you get negative 11 pi over 6. For number 4, you have 260. You're going to multiply by pi over 180. Multiplying straight across, you have 260 pi over 180. Simplifying your fraction, you get 13 pi over 9. So for 5, 6, 7, and 8, you need your saying Sakatoa, or your saying is, some old hippie caught another hippie tripping on asphalt. So this is your sine of theta equals O over H. Your cosine of theta equals A over H. And your tangent of theta equals O over A. So your O, A, and H is your adjacent, opposite, and hypotenuse. So for each of these, you can identify which one you have. So for number 5, we have our adjacent side and our hypotenuse side. So because we have an A and an H, we are going to be using our cosine. So cosine of 29 degrees equals our adjacent, which is 9, over our hypotenuse, which is x. Now, I'm only going to do this one time. To solve this without the trick, you would multiply both sides by x. Division of x and multiplication of x cancels out. You're left with x times cosine of 29 degrees equals 9. You would divide by the cosine of 29 degrees on both sides. Cosine of 29 divided by cosine of 29 cancels out, and you're left with x equals 9 over cosine of 29 degrees. You would put this in your calculator. Now, remember, the trick is, if you can remember, you can simply switch your cosine of 29 degrees and your x and get the same thing without doing all of these steps that I just did. But you can put it in your calculator. You have 9 divided by cosine of 29 degrees, and you will get x is at 10.3. So I rounded it to the 10th place because my direction said 10th place. Please pay attention to that tomorrow. For number 6, we have our opposite side. We also have our hypotenuse. So looking at our saying, we have O and H, so we're working with sine. So sine of 53 degrees equals our O, which is 18.6, over our H, which was X. So we switch it, so we have X equals 18.6 over sine of 53 degrees. We put this in our calculator, making sure that our mode is in degree mode. It has to be in degree mode because our angle was given in degrees. So we get x equals 23.3. Number 7, we're finding our theta. So we have our adjacent side, and we have our hypotenuse side. So A and H again, we're dealing with cosine. Cosine of theta equals our A, which is 11, over our H, which is 13. To get theta by itself, you have to take the inverse of cosine. You cannot just divide it by cosine. It doesn't work. So we have the inverse of cosine theta, and what you do on one side, you have to do to the other. So inverse of cosine and cosine cancels out. You're left with theta equals, and you can put this into your calculator. It is second cosine. So once you put this in your calculator, you get 32.2 degrees. For 8, you have your opposite. You also have your adjacent. So O and A is tangent. So we're going to have tan of theta equals O, which is 9.5, over our 3. So to get theta by itself, you have to do the inverse of tangent. What you do on one side, you got to do to the other. Inverse of tan and tangent cancels out. You're left with theta equals, and you put this into the calculator. Once you put it into the calculator, you will get 72.5 degrees. Okay, so 9 through 14. I'm not going to do it 10, 12, or 14 because you're just putting it into the calculator as it seems, exactly how it looks. But for 9, 11, and 13, you have to know your reciprocals. So if we were given our cosecant of theta and we wanted it in the terms of our sine, cosine, or tangent, we would have 1 over sine of theta. So biggest thing that I kept on reminding you guys is that it changes the letter. So C goes with S. If we were given secant, of theta. The inverse, or the reciprocal, would be cosine of theta. So again, the letters switch on you. And then tangent, the reciprocal of tangent is 1 over cotangent of theta. So using this, we can change our 9, 11, and 13. So we can put it in our calculators. Number 9 would be 1 over sine of 340 degrees. And you will get negative 2.9238. 11, you would change it to 1 over cosine of negative 583 degrees. And you would get negative 1.3673. And 13, change it to 1 over tangent of 638 degrees. And you will get negative 0.1405. So 15 and 16, we needed to find a positive and negative coterminal angle for each angle. So we take our 16, we're going to add 360 to it to get 376 degrees. That would be your positive answer. Also going to subtract 360 degrees to get your negative 344 degrees. So there is your positive, there is your negative. The reason why we were adding and subtracting 360 degrees is because we were asked to find coterminal angles. For 16, we are going to add or subtract 2 pi because we were asked for coterminal angles. So we can subtract 2 pi. If we're subtracting 2 pi, we will get negative 13 pi over 36. Now that's our negative. Now, if you are using your calculator, a way to put it in the calculator is parentheses 59 divided by 36 minus 2. And then if you're using your graphing calculator, you can go to math button and select the little arrow that says fraction. And then hit enter. When you hit enter, you get negative 13 over 36. That is when you have to remind yourself to put that pi back in there. If you keep the pi in there and put it in the calculator, it is not going to give you a simplified fraction. It's going to stay as an ugly decimal. So there was your negative. If you add 2 pi, you will get 131 pi over 36. So there's your positive coterminal angle. For the second side, 17 and 18, the easiest way to do 17 is say, okay, this section is worth 90 degrees. Second section's worth another 90 degrees. Third section is worth 90 degrees. And then this last section is 65 degrees. So 90 plus 90 plus 90 plus 65 gives you 335 degrees. For 18, so this one we kept going around for a while. So we go all the way around. So that would be 2 pi. We go around again. So that'd be another 2 pi. we go half of a circle, so that would be plus pi, and to go the last little bit is plus pi over 6. Now, if you cannot visualize this, you can put it in the calculator. If you wanted to put it in the calculator, you would do 2 plus 2 plus 1 plus 1 over 6. Do the math fraction keys, so it would simplify for you. You would get negative 31 over 6. But you want that pi in there. So your answer is negative 31 pi over 6. So 19 we needed to sketch it. So we're going to go all the way around the circle once and then end up at 250. We're going positive. So positive 360 and then another 250, so not quite to 270, somewhere in the third quadrant. For 20, we have 2 pi over 3. So if you need to label your axes or your barriers of your quadrants, so 0, pi over 2, 1 pi, and 3 pi over 2. So 2 pi over 3 is past a half of a pi. So if you need to convert this pi over 2 to 0.5 pi. And then you can also convert that 2 over 3 to 0.6, repeating. So we are past our pi over 2. So this would be our angle for number 20. For 21, we are finding a reference angle. So I would always sketch these reference angles. That's up to you, but if you do not give me a sketch, I cannot help you for partial credit. So if we sketch it, we are going all the way around. And when we go all the way around, we are left with 55. So there is our angle. Our reference angle is coming from going back to our x-axis. So how I found this value is subtracting 360 from our 415 to get 55 degrees. And that would be our reference angle. For 22, we're going to sketch it. So we're going to go all the way around. Once we go all the way around, we're left with 265, so somewhere in the third quadrant. So to find our reference angle, we want to go back to our x-axis. How we find that measurement is subtracting 360 from it, so we would get 265. So that 265 is after we went all the way around to our terminal side. Now we only want our reference angle, which is here. So we want to take our 265 and find the difference of our 180, because that's the x-axis we're heading to. So 265 subtract 180 gives us our 85 degrees, and that is our reference angle. 24, while we're here, trick with radians is just ignore the coefficient. So your reference angle would be pi over 4. 23, you would ignore your coefficient, so your reference angle would be pi over 6. So 25 through 30, you have to use your table. So let's create our table really quickly. So we have 0 in radians of 0. You have 30 degrees with radians of pi over 6. Then you have 45 degrees with pi over 4. 60 degrees. I'm going to have to scoot this over. So 0 with radians of 0. 30 with pi over 6. 45 degrees with pi over 4. 60 degrees with pi over 3. And 90 degrees with pi over 2. Then you have your sine of theta, cosine of theta, and tangent of theta. So there is your table. So the steps are, in the first row where it says sine, you're going to label it 0, 1, 2, 3, and 4. In the second row, you're going to label it 4, 3, 2, 1, and 0. Your third step is to take the square root of all of them. And then the fourth step is to divide by 2 of all of them. Now you simplify. So in the first box you have the square root of 0, so that simplifies to 0. 0 divided by 2 is just 0. The square root of 4 simplifies to 2. So 2 divided by 2 is 1. So your tangent is sine divided by cosine, which is the same thing as 0. Next column, you have the square root of 1. That simplifies to 1. So you will have 1 over 2. The next box, you have the square root of 3. It does not simplify, so you just have the square root of 3 over 2. Now, the tangent of 30 is where it gets a little bit complicated. You would have 1 over, let me change the color. You have 1/2 divided by the square root of 3 over 2. So this changes to 1 over 2 times 2 over the square root of 3. So keep, change. Multiplying straight across, you have 2 divided by 2 times the square root of 3. 2's cancel out. You're left with 1 over the square root of 3. Then you have to rationalize. So to rationalize this, you have to multiply by the square root of 3 in the numerator and the denominator. So you would get the square root of 3 over 3. So that would be your tangent of 30 degrees. So sine of 45 degrees, you cannot simplify the square root of 2, so it stays the square root of 2 over 2. Same thing with cosine, same thing. So the tangent of 45, you have the square root of 2 over 2 divided by the square root of 2 over 2. Any number divided by itself is just 1. So sine of 60, you have the square root of 3 over 2. Cannot simplify the square root of 3, so it stays the same. cosine of 60, the square root of 1 simplifies to 1, so you have 1/2. For the for tangent of 60, similar to the tangent of 30, but a little bit more simple because you do not have to rationalize. So you have the square root of 3 divided by 2, all over 1/2. Changes it to the square root of 3 over 2 times 2 over 1. Multiplying straight across, you have 2 times square root of 3 over 2. 2's cancel out, and you're left with the square root of 3. So sine of 90, you have the square root of 4, that gives you 2. 2 divided by 2 is 1. The square root of 0 is 0. 0 divided by any number is 0. And tangent of 90 is 1 over 0, which is undefined. So using this table, we can now answer 25 through 30. So we're looking for reference angles. It does not say in the directions, but that is what you use to find your exact values, because we definitely do not have angle measurements of 570 on our table, or negative 720. So let's find our reference angle. So I like to sketch it. If you don't need to sketch it, that's perfectly fine with me. So sketching this would be roughly in our third quadrant. You would go positive all the way around, and you would be left with roughly 210. So this part here would be your 210. Now you want to go backwards, back to this x-axis, and that would be 30 degrees. So you're looking for a sine of 30 degrees. So sine of 30 degrees is 1/2. Now we have to ask ourselves, is it going to be a positive 1/2 or a negative 1/2? Well, we've got all students take calculus. So only tangent is positive in that third quadrant. So sine is negative. So that is our answer. For 27, I'm just going to keep going on this side. If we want to sketch our negative 300, we would be roughly in the first quadrant, go all the way around. Our leftover angle would get us to negative 360. Our reference angle is going to be 60 degrees. So cosine of 60 degrees on our table is 1/2. So our answer is 1/2. Now, because we're in the first quadrant, we can look at what we wrote for 25. All of them are going to be positive in the first quadrant. So it's going to be a positive 1/2. 29 gets a little bit more complicated. So first, let's find our reference angle. So if we sketch this, if we subtract 360 twice, we're left with 120. So approximately in the second quadrant, and we go around negative 2 times. So there is your sketch of your angle. So we want to notice that this last part is at negative 120. My mistake, guys. Let's do that again. we go all the way around twice. And the last part is our 120. So right here. So our reference angle is going to be getting to that 180. Getting to that 180, we have 60 degrees. So we want the secant of 60. Well, if you look at your table, there is no secant. So we got to change it in terms of one of our trig functions we do have in our table. So if we change it, we're going to change it to 1 over cosine of 60. When we do this, now we can look at our table. Cosine of 60 is 1/2. So this gives us 1 over 1 divided by 2. Changes it to 1 times 2 over 1, which gives us 2. Now we have to look back at our sketch of our angle. We're in the third quadrant. Cosine is not positive in the third quadrant. So our answer is going to be -2. All right, 26. 26, we want to sketch our angle to get our reference angle. So we're going to go all the way around. So that's 360. Another 360 would actually be -720. So we end up at the same spot. So our reference angle, we don't have to go anywhere. So our reference angle would be at secant of 0. So we want to have it in terms of one of our trig functions in our table. So we have 1 over sine of 0, which will give us 0, looking at our table. Tangent of 0 is actually on our table already, and we get 0. Cotangent of -810, we can sketch this. So we go around twice, and it's negative. 1, 2, and then you go -90, so right here. So your reference angle, you're looking at 490, because to get to either the x-axis on the left side or the x-axis on the right side, it does not matter. You still have to go 90 degrees. So you're looking for cotangent of 90. Cotangent is not on our table, so we have to change it to 1 over tangent of 90. So tangent of 90 is 1 over 0. So 1 over 0. You change it to 1 times 0 over 1. You get 0. So your answer is 0. For 31, we want to sketch it. So we want to sketch our problem to calculate the height of a tree. So here's our ground. Here's our little Christmas tree. No, it does not have to be a Christmas tree, but a Christmas tree is the easiest thing to draw. And our point on the ground is over here at point A. Our angle of elevation to the top of the tree is 34 degrees. And the measurement from point A to the bottom of the tree is 8 meters. So the question is, how tall is the tree? So here we're looking at our opposite side and our adjacent side. So O and A is tangent. So we're doing tangent of 34 degrees equals our x over 8. For this, we do not have to use the trick because we're getting our 8 out of the denominator. So we're multiplying 8 on both sides. Division of 8 and multiplication of 8 cancels out. You're left with x equals 8 times tangent of 34 degrees. Put this in your calculator and you get x equals 5.4 meters. And you do need to round to the nearest tenths because that is what it asks for. 32. 32 tells us that we have a 14.5 meter tall building. It casts a shadow onto the ground at 11.4 meters long. So then it asks what angle does the rays of the sun hit the ground to the nearest degree. So it is actually referring to the angle from your horizontal line to the ground. So this theta is the same thing as the elevation theta measurement because of alternate interior angles. So now that we have it set up, we have our opposite side and our adjacent side. So we're still working with tangent of theta equals 14.5 over 11.4. We're going to take the inverse of tangent on both sides. Our inverse of tangent and tangent cancels out. You're left with theta equals, you're going to put all of this into the calculator by doing second tan, and then you get 52 degrees. And that is your answer. That one you are rounding to the nearest degree. Again, if you have any questions, please email me and I will try to answer.